Hi, I'm Arvil Price with America's Choice Inspections. Today we're hearing so much about green, we're even hearing the term greenwashing, which means manufacturers or builders sometimes call their product green just so the public will like it. Many MLS sheets across our state now have several green categories. This one has a place for green certification and another green category called HERS. Some agents still think this could mean the 2 closets in the master suite. But HERS means Home Energy Rating System Index. ENERGYSTAR is a joint effort between the Department of Energy and the Environmental Protection Agency. And it's one of the most popular green certifications for residential construction. For energy conservation, better comfort, and healthier living, ENERGYSTAR focuses on 6 components: effective insulation, high-performance windows, tight construction and tight ducts, efficient heating and cooling equipment, efficient products, and lastly, third-party verification. Earlier we mentioned the term HERS index. A home built to code has a HERS index of 100. The more energy efficient we build our home, the lower the HERS index. For a home to become ENERGYSTAR certified, it must have a HERS index of at least 85 or lower. Today I want to take you on site and walk you through a home in the pre-drywall stage to see some of the things builders are doing to improve efficiency. We will meet a third-party HERS rater to see some of the techniques he uses to see if builders are meeting ENERGYSTAR objectives. Okay, so today we're out here on site at pre-drywall home with Sam Goffin. Thanks for being here, Sam.
My pleasure, Arvil.
And Sam's a HERS rater with Performance Point. Sam, briefly tell us a little bit about your background and what's involved in becoming a HERS rater.
Sure. Well, Arvil, I went to school and got an undergrad degree in engineering, which definitely helps with the energy rating side of things. To become a HERS rater, it takes some additional schooling and then also some field and work experience, which you have to have signed off on by another HERS provider.
Okay. And we know that one of the things that's required for ENERGYSTAR is effective insulation. Sam, what is effective insulation?
Right. So when we look at a house's insulation in the exterior walls, we don't only look at the R value on the insulation, but we're also looking at the quality that it's installed with. So code will mandate certain R values in the walls, but the code doesn't really talk about how well that needs to be installed. When we come to look at a house, that's most of what we pay attention to is how well is this batting installed on this wall. This is very close to a grade 1 installation, which is a perfect installation for batting. It goes all the way down to grade 3, and the effectiveness of that insulation varies greatly between a grade 1 being very effective and a grade 3 being ineffective. Some of the other things we can see on this exterior wall while we're here are some air sealing details. This wall has a band across the top where you can see lots of air sealing has gone into, and air barriers and blocking has gone into play here on this band.
Okay, so expanding on this issue, effective insulation. And we're now out in the garage, and Sam, I so often hear people complaining about the bonus room over the garage either being too hard to cool in the summertime, too hard to heat in the wintertime. And actually the home I live in now, which is not an ENERGYSTAR home, in the wintertime that floor is very cold. What's going on with this, and how do we alleviate this issue with effective insulation?
Right, so the bonus room is most often exposed on 5 sides to the outside air. That can be attic on the top, the garage underneath, and then some kind of knee wall and an exterior wall on the other sides. So effective insulation is really what we need to alleviate that problem of hard to heat and cool. And right now we're looking up at this floor, and what we see is the batting in this floor is pushed all the way up to the floor system, and it's held in tightly in place, but not overly compressed. When we compress insulation, it loses its R value. Yet, if this is not touching the floor, then it can't do anything good. So what we've done is we've really taken great care to hold this in place without compressing it. Another thing you'll recognize here is around the outside of this, we have air barriers up installed. And so when we look at these air barriers, we're really making this insulation work for us. Without an air barrier, this type of insulation can do no good.
So Sam, we're standing in this room over the garage, and behind this wall is attic space over the garage. And I know this is going to be the door to access that attic space. And typically, if we look through this door on either side, we're going to see this insulation. Now, what are we doing with the ENERGYSTAR to help make these spaces over the garage more energy efficient and have that effective insulation?
Right. So just like we were talking about with the floor below this area earlier, where we showed the batting being pushed all the way up to the floor system and not compressed. We have the same thing here, like we were looking downstairs when we had the batting too compressed, it wasn't going to touch the insulation, the air barrier on the front side, the sheetrock. This piece of batting here, if I pull it back, you can see there's an air barrier behind it. Typically, if I were to do that in a house, there would be no air barrier on the back side of it. You'd be looking right into the attic area. This is one of the main reasons that bonus rooms are uncomfortable. It's because without this insulation touching air barriers on all 6 sides, it cannot work effectively. So Arvel, we're still talking about effective insulation, but now we're standing in the dining room. One of the things that we talked about in that garage area was the fact that that insulation needs to be up, touching the floor system. Well, we have that same thing happening here. This piece of batting is not properly installed. It will not be an effective piece of insulation. The reason is because it's not touching the surface we want it to insulate. Batting has to touch an air barrier on all 6 sides when it's in a wall like this. It's touching the back, it's touching these sides, it's touching at the top and the bottom, but when the sheetrock's installed here, it's not going to be touching the front.
That's where it's chinked in. It's just too tight. Sam, it wasn't trimmed off enough, so it's causing it to...
That's exactly right. If they cut this before they put it in, it'd be the right size and it would fill this whole cavity instead of being shoved in there. So it's not going to be touching the front side of this sheetrock, and that means it's not insulating the sheetrock at all. It's also shoved in here. When the batting is compressed like this, all along these edges, that means it's losing its R value. This is not effective installation.
I think once I heard y'all use the analogy of when this insulation is not in contact with sheetrock, it's kind of like you can have all the blankets on your bed you want, but they're not in contact. If we have an air gap of an inch between the blankets and our body, they're not doing any good. That's very interesting.
That's exactly right. It's like having a blanket that's sitting on the floor instead of on you, or like putting on a jacket and not zipping it. If you don't zip your jacket, if it's not in contact with you, it's not keeping you warm. We also have over here something else. Right here in this little T-wall, which a T-wall is where 2 walls intersect, we have insulation behind this T-wall. Typically, this T-wall would have no insulation behind it. It would just be solid framed with wood. Wood is an R value of 1 per inch. So that makes this about an R3 or 3.5 section. Right now, with the way we have the batting installed behind here and the way this is framed, we're getting an R13 value in this T-wall. That's a big improvement. Another place we see a big improvement is over your head here in this window header. This window header is actually insulated with styrofoam. When we frame these headers, instead of putting a piece of lumber and then a thin piece of lumber and then a thick piece of lumber again to make the header, we don't need all that wood. Structurally, there's no need for that. So what we've done is we've taken out the thin piece of wood in the middle called a flitch plate, and we've replaced it with styrofoam blue board. That takes this header from being an R3 to now it's an R6. We've doubled the R value of this header.
Sam, we're starting to see this shiny material show up on the roof deck. I know last summer I was in a couple houses with this material, and it was much more comfortable in the attic. What is this, and what are we doing with this product?
This product is actually called a radiant barrier, Arvel, and it's the roof decking itself has laminated to the back side of it in aluminum foil. That aluminum foil keeps radiant energy from being able to enter the attic and like it does with just plain OSB. The attic is heated in a typical home by sun hitting the shingles, warming up the shingles, and then that heat transfers through the decking and radiates into the attic. It's radiating heat to all the surfaces in the attic and making the attic warm up and get very hot very quickly. With this radiant product installed, the heat can transfer through the shingles the same way, but it can't radiate into the attic. So typically, in our climate zone, we see attic temperatures 30 degrees cooler easily.
You know, Sam, so often we're doing inspections, home inspections, we see a stain around the baseboard, both on interior and exterior walls. Now, I've heard that term called ghosting. What's causing that?
So ghosting happens when your carpet around the exterior walls or interior walls, wherever, is acting as an air filter. The ghosting is actually little deposits of dust and combustion particles, little things like that. They're deposited there in the carpet around the perimeter of the walls, and they're trapped there, leaving a dark spot. That's happening as air is moving under the baseboards and up the walls, or vice versa, down the walls. And one of the things the ENERGYSTAR house has to prevent that is proper air sealing. So one detail here is this air sealing around the baseboards. That's going to help eliminate some of that infiltration. Another detail is this air sealing around the windows. This is done with expanding foam, a product that cannot have air flowing through it, unlike what's typical, which is shoving insulation batting in there, which does allow air to flow through it. These kinds of things, along with the fresh air intake, which we'll look at in a second, help balance the pressure in the house and keep that infiltration from happening in such a way that ghosting will occur.
Sam, we know that another component for ENERGYSTAR is high efficiency windows. What is ENERGYSTAR doing to achieve that objective?
Well, Arvel, depending on your climate zone, there's two things we look at on the windows: the U factor and the solar heat gain coefficient. This window has a U factor of 0.34. That's an R value of almost 3, like we've looked at the walls. The solar heat gain coefficient is 0.23. That's pretty good. The solar heat gain coefficient is stopping radiant energy from coming into your house, and the way this window is laminated with the films, it actually will stop radiant energy from leaving your house in the wintertime too. That adds a lot of comfort and a lot of efficiency.
Another thing that ENERGYSTAR requires is energy efficient products. You may have heard people going over to a tankless water heater or switching over to an ENERGYSTAR dishwasher, wash machine, clothes dryer, or you may have installed compact fluorescent CFL light bulbs in your home. This package of Sylvania 65-watt light bulbs says that they will save an average of $117 on your energy bill during the lifespan of these 3 bulbs. We set up a demonstration because we wanted to see, is this in fact true, or is it just another form of greenwashing by a manufacturer? So in our demonstration right here, we have a 65-watt compact fluorescent on this side and a 65-watt Sylvania incandescent light bulb on this side. So when we turn off the CFL and we're running only the incandescent, we see that we have a energy usage of 55 watts. But when we cut off the incandescent and we're running only the CFL, we see that we have an energy usage of 14 watts. You know, that's almost 1/4 the amount of energy that is required by our incandescent. Quite a bit of savings. But another thing to consider is that our incandescent puts out a lot more heat than our compact fluorescent. So in the summertime, when we're trying to keep our homes cooler, we're having to fight against the amount of heat that an incandescent is producing inside the home. Well, Sam, that was really interesting going through the pre-drywall home and seeing all the things you're doing today to seal up these ENERGYSTAR homes. And now that the home's finished, what are you doing now?
Well, Arvel, two of the biggest things in the house that make up the HERS index and the utility bills and the comfort of the house are air infiltration and duct leakage. This tool right here is called a blower door, and this helps us measure the air infiltration of the house. We depressurize the house to 50 Pascal, and we measure the amount of air that it takes to keep it at that pressure. Right now we're getting about 1,500 CFM. That's cubic feet per minute. So if you think of a box that's 12 by 12 by 12, being 1 cubic foot, we're moving 1,500 of those through this fan every minute. In a non-ENERGYSTAR house, we'd be looking at 2,000 to 2,500 cubic feet per minute for this home.
Wow, that sounds like a big difference.
It is a big difference. All that air sealing we looked at pre-drywall makes a big difference when we come to do this test.
I'm often asked, Arvel, can we seal our homes up too tight? Well, we have a saying, seal it tight and ventilate right. Anytime we're running our clothes dryer or otherwise pushing air out of the home, every cubic foot of air has to be made up from somewhere. And this source is often from the exterior, our attics, or our crawl spaces. With ENERGYSTAR, all of our homes have a duct that runs directly to the exterior, so we have a fresh air intake for any time we need makeup air. But unlike traditional methods, this air is first ran through a filter of no less than a MERV 6 rating. Also, in the spring and fall months when the outside air is at a temperature where our thermostats are not inducing the air handler, these more advanced systems are engaging the fresh air intake to keep an adequate supply of clean air in the home. So often when I'm inspecting homes, I see HVAC return filters that are so dirty that they have become concave, and I can actually hear the air handlers straining to get air to the system. Also, when we inspect windows, the first thing I have to do is raise the blinds. When a cloud of dust flies through the air, it is another indicator that return filters are not being changed on a regular basis. And of course, we've all seen the huge amount of particles floating in a beam of sunlight shining into a particular building that we've been in at some point in time. The EPA has listed indoor air quality as one of the top 5 environmental health risks to public health. It is estimated that the average American spends as much as 90% of their time inside a building or their car. These indoor levels of pollutants may be 2 to 5 times higher than the outdoor levels. When discussing this topic of indoor air quality, I'm often asked, Arvil, what kind of air filter should I put in my home? When making this decision, you should start with the MERV rating of a particular filter. MERV is the acronym for Minimum Efficiency Reporting Value, which is the industry standard for rating used to measure the effectiveness of air conditioner filters. Ratings for residential and commercial air conditioner filters typically fall between MERV 5 and MERV 12. Filters with higher MERV ratings remove more small particles from your air than lower rated filters. Sometimes we see these spun fiberglass filters which only have a MERV rating of between 1 and 4. These filters are not very high quality and need to be changed out at least every 30 days. ENERGYSTAR requires us to use a filter with a MERV rating of at least 6. You can see how this one is tighter and pleated for more surface area. This one can stay in your system for up to 90 days, but there are a lot of things you should consider when deciding how long to use a filter. If you have pets, use candles, burn a fireplace, have ongoing construction projects, or smoke cigarettes, this will definitely reduce the time your filter can remain effective before it should be changed. This filter has a MERV rating of 8 and contains electrostatic fibers that help to attract and capture even more particles and allergens. Now for superior results, I like this 4-inch accordion style filter. These filters are a lot tighter and usually have a MERV rating of at least 10, but they also have a lot more surface area to allow airflow. This filter also contains the electrostatic fibers to do an even more effective job of attracting and capturing particles and allergens like pollen, mold spores, dust mites, lint, smoke, pet dander, household dust, bacteria, smog, and particles that can carry viruses. With all the surface area, this filter can last up to 12 months before needing to be replaced. Filters with a MERV rating higher than 13 start to restrict airflow and can start to put stress on your system and driving your utility bills up. These filters are usually designed for commercial use like hospitals and clean rooms. Well, Sammy, one of the things with ENERGYSTAR that I've been most impressed about is everything that you're doing with the HVAC equipment, or specifically the ductwork. We just left that pre-drywall home, and typically as a home inspector, when I go to a crawl-space attic, I'm seeing all these ducts kind of go loop-de-loop-de-loop. These all made very straight runs, and then when you got to the air supply, to the duct, they were completely sealed up, so you couldn't actually see any of that sheet metal in that boot. And when I looked up inside the boot, we were able to see all the mastic, so that seamless sheet metal was completely sealed up. Now, what are we doing here in the home once it's finished?
So the duct system can represent upwards of 40% of the heating and cooling load on a house. A big part of that comes from duct leakage. Just like we talked about the air infiltration, the house leakage, making a big impact on the HERS index, so does the duct leakage. This is basically like a small blower door. And what it does is depressurize the duct system, and we measure the amount of air that it takes to keep it at that pressure. The same way we did before. We know how much air is coming through this fan, so we know how much air is coming into the ducts through gaps and cracks. First, we seal off all the registers and supplies, and then we come back and we test it with this fan. In an existing home, what we find as a typical duct leakage is around 20% leakage.
Another topic we talk about in green building is clean air. And traditionally, North Carolina has always been a tobacco state, and lung health just was not a popular topic for discussion. Then in January 2005, the Surgeon General put out a health advisory saying that radon is the second leading cause of lung cancer, second only to cigarette smoking. Following that advisory is when radon was elevated from the addendum level, making it to your offer to purchase. This home is equipped with a radon reduction system called a sub-slab suction system. The pipe penetrates the slab foundation and goes all the way up through the roof deck. The inline fan located in the attic pulls the radon gas out from under the slab before it has the opportunity to get trapped inside the home. I find it ironic that while the EPA tells us that we have more than 7 times as many deaths from indoor radon gas than we do from home fires. All of our homes are required to be equipped with smoke detectors, but we're just now seeing an increase in radon reduction systems. Having a radon reduction system in your home is a great feature for ensuring cleaner, healthier air. You know, I remember growing up, we used to use a chemical to treat termites with called chlorodyne. And chlorodyne was great for killing termites. Problem is, it killed anything it came in contact with. Over time, we started finding more and more environmentally friendly ways of treating termites. In this particular home, it's not required for ENERGYSTAR, but it's certainly a very environmentally friendly way for treating for termites. This green dye indicates that they used a product called Boracare. And Boracare is made from borates. Borates is a naturally occurring substance that is mined out of the ground and is safe for humans, yet is resistant to termites. I hope you've enjoyed the tour of this ENERGYSTAR home. You know, while trying to come off the grid just isn't a feasible goal today, there are lots of things we can do that are very inexpensive that can help us drop our energy savings by at least 15 or 20%. I think this is the low-hanging fruit that we should be focused on.